Okay, what we're going to do is we're going to split this lesson over 2 days. The concept is solving linear equations, and this will go back over stuff that you've done in Algebra 1. Again, we're taking it slowly to reinforce that groundwork before we get into concepts that are newer. This lesson hopefully began with an in-person demonstration of getting dressed and the idea that the last thing you do is the first thing you undo. So in algebra, we talk about order of operations, and in algebraic expressions, we talk about what you do first, what you do second, and so forth. The key idea in solving linear equations is that we reverse the operations that we've done to the variable. So whatever we did last will be the first thing we undo. So I'm going to put an equation up here, and we're going to really talk through what's being done and what's being undone and the justification for the steps that we're taking, why we're not changing the structure of the problem or the truth of what's written. So we're going to keep it really simple. This is 2x plus 3 equals 5. This is what's called the two-step linear equation. I hope that everybody in here can solve it. So I'm not super concerned right now about whether you are able to figure out the value of x. What I'm concerned about right here is whether you understand the reasoning and the rationale behind why you take the steps that you take. So in order to think through it, I'm going to create two columns over here on the right. We're going to create a do column. And what we're going to think of when we write out what's in this column is what are we doing to the x? So the first thing is we start with an x. So I'm going to write over here, we start with an x. Here it is. What is happening to that x? Where there's two things that are happening to the x. We have multiplication happening between the 2 and the x, and we have adding to the x. We're adding a 3. So order of operations dictates what order we're going to do those things in, and order of operations says we do multiplication before we do adding. So the first thing happening to that x is it is being multiplied by 2. And I'll write that down. Then after we take the x and multiply it by 2, then we add 3. And this list right here tells us what we have done to the x. And I'm going to draw an arrow going down. So we start with x, we multiply by 2, and then we add 3. And when we do that, we end up with something equal to 5. So when we go to solve this equation, what we are going to do is undo what has been done. That's this idea of inverse. It's the idea that subtracting undoes adding, or multiplying undoes dividing. And we have these pairs of operations called inverse operations. So we undo things in the reverse order. So if the last thing that I did was add a 3, then the first thing I'm going to undo is adding the 3. Well, how do I undo adding a 3? I subtract 3. And so that is why when you're solving a linear equation that you start with undoing the adding or subtracting. And sometimes I've heard this explained in middle school classes or Algebra 1 classes as, well, you start with what's furthest away. Well, yes, but why? Why should you start with what's furthest away? Why shouldn't you just start with the first thing you see, which is probably the 2, and say, well, I'll start by dividing by 2. The reason for that has to do with that illustration of the last thing you put on is the first thing you take off. The last thing you do is going to be the first thing you undo. So if the last thing we did was adding 3, then the first thing we're going to do when we're trying to go backwards is undo the adding. And we'll do that by subtracting 3. That's the reasoning there. Okay, now we're going to apply some of these properties. Anything you're not dealing with, you're going to bring down. We always work our math problems top to bottom, top to bottom, top to bottom, not stringing it out over here. Okay, don't do that. I'm going to bring down the 2x. Now I'm going to write something here that I don't normally write, and I don't expect you to write it either. I just want you to know and understand that it's happening. This is this inverse property. If I have 3 plus negative 3 or 3 minus 3, that is equal to 0. That is the reason why we are subtracting. So if I were to ask you, why are you subtracting? You would answer because 3 minus 3 is 0, or 3 plus negative 3 is 0. That's the reason why you're doing the subtraction. I can't tell you how many times I've seen students write plus 3, and then they draw a line through it like it cancels out. Plus 3 gives you plus 6, not 0, and we want to get the 0. If I had a minus sign right there, I would add 3 to get the 0. 2x plus 0 is just 2x. So that's why the 3's cancel out. It's so important that you see that and understand it. If it's obvious to you, fantastic. But if nobody's ever showed that to you or explained to you why the 3's are gone, it's because they add up to 0. Now let's move on with this process. The next thing in my list was to multiply by 2. Well, how do I undo multiplication? I undo it with division. And I don't know if I can fit that in there, but divide by 2. I'm going to undo that multiplication by division, and that's why we put the division symbol as the fraction bar. And we do the same thing to both sides because we want to keep it balanced. Whatever I do to the left, I have to do to the right. Otherwise, they won't be equal anymore. So what is 2 divided by 2, or 2 times 1/2? That is equal to 1. 2 divided by 2 is 1. 2 divided by 2 is 1. Normally, you would not write the 1x, okay? It's redundant, and a lot of times we'll just draw a little line through it. We'll say the 2's cancel out, and students don't really understand why they cancel out. And I've seen students write minus 2, minus 2. You don't undo multiplication with subtraction. So we really want to understand that this is multiplication. We undo it with division, and the reason why they cancel out is because 2 divided by 2 is 1. And now we have that identity property again. 1 times x is just x. And so x is equal to 1. So we've got these two properties at work, that inverse property and that identity property. Just like we started with x, when I go through this whole process, I will end with x. And when I rework the problem or go to solve it, I go in the opposite direction. This is what I did, and this is what I will undo. So to solve this problem, we subtract 3, then we divide by 2, and we will end with x just like we started with x when we first looked at the problem. So again, the reason why we take the steps that we take are because we get the zeros and the ones, and that's what causes the pieces of the problem to drop out and do what we call isolating the x. Super, super, super important. So what I'm going to put on the next slide is I'm going to show you my steps for solving linear equations, and I'm going to work an example right next to it. So let's go ahead and do that. Okay, these are the steps that I'm giving you for solving linear equations. If you follow these steps, you will be able to solve every single linear equation in the universe perfectly every single time. So take a moment if you are at home or you're re-watching this after having seen it in class, and I want these steps copied into your notebook. When I do this on the board, I will often color code the steps, which is kind of nice, but I can't color code in this program. So step 1, clear of fractions if needed. And you really hope it's not needed. None of us really want to see fractions in our problems, but I will show you an example of what that looks like. You won't see tons of fractions in your linear equations. You might if you did Algebra 2 at the honors level. They would throw more fractions at you, but you won't see it too much. Then you'll simplify each side separately. Well, what do we mean by sides? First of all, each side means each side of the equal sign, and you're going to simplify them independent of each other. So you'll simplify the left side and you'll simplify the right side. By simplify, we mean distribute and combine any like terms. Step 3, this is where I lose a lot of Algebra 2 students. This particular step does not, for whatever reason, get clear in Algebra 1, but you're going to get the variable on one side, and then you will solve the resulting 1 or 2 step equation. And at that point, you will have a 1 or 2 step equation, which I believe all of you can solve. So let's take a look at an example. The first example I have is this, 7, and then in parentheses, a plus 1 minus 3a equals 5 plus 4, and then in parentheses, 2a minus 1. Okay, that's barely made it on there. So I'll read it out loud again because it is messy. 7, and then in parentheses, a plus 1 minus 3a equals 5 plus 4, and then in parentheses, 2a minus 1. So we're going to follow these steps exactly as they are written. Don't deviate from the plan. Like, the plan will work, so don't deviate from it. Step 1, clear fractions if needed. Well, the good news here is that the fractions are not needed. We don't have any fractions, so we don't need to do step 1. Step 2, simplify each side separately. So we're going to look at the left side, and we're going to simplify that separate from the right side. So there's no combining stuff from the left and the right side. Think of this as like a room divider, okay? Nothing happening in between the two rooms. First thing is to do any distribution. Well, I do have some distribution right here. I can distribute the 7 through that parenthesis and get 7a plus 7. And then I will bring down the minus 3a. Make sure that you bring everything down that you're not working with. On the right-hand side, I also have some distribution. I can distribute the 4 through the parentheses. So that would give me 5 plus, and you're welcome to do the little arrows here, but don't feel like you have to. 4 times 2 is 8. So I have 8a, and then 4 times negative 1 is negative 4. That is a negative 4 out there. After you've done any distribution, then you're going to combine like terms. Now, don't combine this a with this a over here on the right side. You're keeping the left side of your equation separate from your right. Is it possible for you to combine them by adding 3a to both sides? Yes, but I don't want you to do it. We're going to follow the plan. On the left-hand side, I have 7a and I have a minus 3a. So I'm going to circle those as like terms. Make sure that you understand that you are going to subtract 3a or plus negative 3a. So this is actually a negative 3. 7a minus 3a gives me 4a. Sometimes I'll put like a word in there. 7 apples, take away 3 apples gives you 4 apples. Like, go back to the first grade way of talking about it. We're not doing anything with the plus 7, so we are going to bring the plus 7 down. On the right-hand side, I don't have any other a's to combine with, but I do have a 5 and a minus 4. So that is 5 minus 4. 5 minus 4 is 1. And bring down the 8a. I said before, your work goes top to bottom. So every single line in this comes from the line above it. If I were to ask you, where did you get 4a? You would tell me you got 4a from doing 7a minus 3a. If I were to ask you, where did the 8a come from? You would say, I just brought it down from the line above. So every piece of your line is accounted for doing something from the line above it. Now the next step is to get the variables on one side. So I have a's on the left and I have a's on the right. And we can't solve the equation with the a's on both sides. So what we want to do is collect all the a's on one side. If I look closely at this, I will notice this is a positive 4a. How can I get rid of a positive 4a? Well, using that inverse property, if I subtract 4a, 4a minus 4a would give me 0. And that would cause them to cancel out. 4a minus 4a is 0. Don't add 4a. 4a plus 4a gives me 8a. We want a 0 there. If I subtract 4a from the left, I also have to subtract it from the right, and make sure you subtract it from the like terms. A's get subtracted from other a's. 4a minus 4a is 0. Bring down that 7 equals 1. 8a minus 4a is 4a. Now, normally you would not write that 0. I don't actually want you to write the 0. I just want to emphasize that it's there. And then the last step, solve the 1 or 2 step equation. Well, this is 7 equals 1 plus 4a. If you don't like it written like that, you could write 4a plus 1 equals 7. You can switch the 4a plus 1. That's a commutative property. You can also switch the side of the equal sign if you wanted to. That's something called the symmetric property. To isolate this, this is a positive 1. So I would subtract 1 from both sides. And again, the reason you're subtracting it is because 1 minus 1 is 0. Even if you had a minus sign there, the 1 is still positive, and we're working top to bottom. So 1 minus 1 is 0. That's why they're going to cancel out. And that is going to give me 6 equals 4a. Remember that that is 4 times a, and I will undo, that's a 4 down there. Running out of space. 4a divided by 4 would give you 1a. That would be 1. And I did run out of space. I'm going to come over here. It's kind of bad form to do that, but it's where I have space. And then the last thing you could do here is simplify that fraction. If you're terrible at simplifying fractions, I can show you how to do it on your... Okay, I messed up my app on my iPad here. I can show you how to do it on your calculator. And we end up with a is equal to 3/2. And at this point, half of my students panic because that's not an integer. It's a rational number because it's a ratio, but it's not an integer. But don't panic. You can get fractions as answers. So take a moment if you're watching this on your own or you're rewatching it. Pause it right here. Make sure you've copied down the solution, because what I'm going to do in the video is get rid of all my scratch work here and set up for the second example. Okay, so we've got our steps still up there, and we are going to look at an example with some fractions, because that first step is to clear of fractions. And we want to at least look at what that looks like. So first thing you do when you see a problem like this is you're probably going to want to cry or panic or skip it. And it's okay to skip it as long as you come back to it. It's okay to look at an assignment or a test and go and find the problems that look easiest and then come back to the harder ones at the end. Totally okay to do that. It's not okay to skip them permanently. So let's talk a little bit about how we would clear fractions. What clearing of fractions is we're going to multiply this equation by something that's going to cause those fractions to go away. And the easiest way to do that is to look at your denominators. We have a 3 and we have a 2, and multiply those denominators together. Okay? Now, this might result in a number that's bigger than the number that we need to use. As long as it works, I'm not really that concerned about whether it's bigger. So by multiplying the two denominators together, we come up with 6. So what we are going to do is multiply both sides of this equation by 6. Now notice I'm putting parentheses around this, because when we multiply both sides, we have to multiply everything on both sides. If we only multiply pieces of each side, then we'll mess up with the equality aspect of it. Once we've decided what to multiply by, now we have to do a little bit of fraction arithmetic. So to figure this out, I'm going to do 6 times 2/3. So we're going to distribute. What we've done is we've created some distribution. So we're like in that step. Now, if you don't remember how to multiply fractions, you multiply them straight across. It's like the easiest thing to do with fractions. Remember that 6 is a rational number. You could write it as 6/1. And we multiply straight across. So 6 times 2 is 12, and 1 times 3 is 3. And 12 divided by 3 is 4. So when I go to do that multiplication, I just get 4. And then 6 times -4 is -24. Same thing over here, 6 times 1/2. Well, again, that's going to be 6/1. 6 times 1 is 6, 1 times 2 is 2, and 6 divided by 2 is 3. and 6 times -1 is -6. And what that multiplication did by taking that 6 and multiplying it through is now we have an equation with no fractions in it, which is nice. Like, we don't really want those fractions in the first place. So the easiest way to figure out what you need to multiply by is to just multiply your denominators together. It might result in something too big. Like, sometimes you might end up with like a 12 here, but a 12 would have worked as well. We just have bigger numbers in the equation, so it's okay to do that. Now let's follow the plan. So now that we've cleared of fractions, we're going to simplify each side separately. That means distribute. Well, I have no distribution. Combine like terms. Nope, no like terms. We have an x and a non-x on each side. So that moves us to step 3, which is get the variable on one side. I tend to try to keep the variable positive. I did it in the first example. I'm going to do it in this example as well. If I were working this problem out live in class, I would probably ask you guys which way you wanted me to do it. But I like to keep it positive, so I'm going to keep it positive. Now, notice right here, the 3x is positive. What's going to cancel that out and give us a 0? Well, if the 3x is positive, I would need to subtract 3x. Don't look at this minus sign. This minus sign is attached to the 6. It's the 6 that's negative, not the 3x. The 3x is very much positive. So 3x minus 3x is what's going to give us the 0. Pay attention to that. Whatever I do on the left, I have to do on the right. 4x minus 3x is 1x. Bring down that -24. 3x minus 3x is 0. And you're going to bring down the entire -6. So that negative is still there. It's still attached in front of the 6. Last step, solve the 1 or 2-step equation. Well, if I am subtracting 24, I can get my 0 by adding 24 to both sides. And then 1 times x is just x. So we don't have anything else to do there. And then -6 plus 24 is 18. And I did it again. I messed up my app. Hopefully the recording is okay though. All right, so there's our second example, and that shows you what it is to clear of fractions. You won't see that too much. Again, you won't see it too much at the standard level because we concentrate more on the underlying concepts there. But that doesn't mean you'll never see it, and I do want you to have an example in your notes. So again, if you need to, pause this video and make sure you've copied down the steps if you haven't already, as well as the solution to them. Okay, for this last part, this will wrap up this first lesson on solving linear equations. I'm going to give you guys a linear equation, and I would like you to, whether you're at home or here in class, take a moment and work it out in your notebook. And then we will come back together and talk about it. If we're in class, I'll do it like live and I won't do the end of the video. But for those of you working at home, I'll do it out in the video as well. And we'll play that by ear. Getting used to the switching back and forth from video to live presentation. I'll get the hang of it. Okay, so here is the equation you are going to solve. 12 minus 3 parentheses 2w plus 1 equals 7w minus 3 times 7 plus w in parentheses. So I will give you guys several minutes to do this. If we're doing it online, I'll give you some instructions about how I want you to present your work to show me that you are working from home. And then if we're doing it in class, we'll handle it differently. And again, I will do it out in the last part of the video for those of you that were absent and you're making this up through the video so that you're not gypped the discussion. Otherwise, we're going to switch back over to live interaction. Right, so here's the problem, and I do want to go through the explanation just for those of you that are rewatching the video at home for additional explanation, or you missed class and this is the entire lesson that you're going to get. So the idea is that you want these steps to become automatic. We want automaticity. I don't want you thinking really hard about these steps, but we do want to get enough practice to get to that point. So the first step in solving a linear equation is to clear of fractions. And you'll notice that this problem does not have any fractions. So we're good for that first step. Second step is to simplify each side separately. So we're going to take our skills with algebraic expressions and simplify this mess on the left and this mess on the right. And we're not going to combine anything between the two sides. First step in simplifying is distribution. Now, before you go ahead and distribute, I want to point something out. This is what my Algebra 1 teacher, where he made us write plus negative, where he helped us avoid a mistake. When you are distributing here, you're not distributing a 3. You are distributing a negative 3 because you are subtracting this entire chunk of stuff is all grouped together. Multiplication comes before subtraction, and parentheses come before subtraction. So this subtraction is subtracting this whole hot mess of stuff. It might help you to write that as plus negative, seriously? There we go. Plus negative 3 to remind you that when you're distributing a negative 3. Same deal over here. You're distributing a negative 3. One of the most common mistakes that happens in algebra is not distributing that negative. So 12, negative 3 times 2w, you can write either minus 6w, or if you want to keep with that plus negative, you can do plus negative 6w. Remember, there's no such thing as subtraction, so whatever's going to work best for you. And then negative 3 times 1 is negative 3. I'm going to keep it as subtraction because that's where I'm more comfortable, and I think that's where most of you are as well. On the right-hand side, bring down the 7w. Negative 3 times 7 is negative 21. And negative 3 times w is negative 3w. After you distribute, then combine your like terms. On the left-hand side, I have 12 and I have negative 3. That's a positive 12 and a negative 3. 12 minus 3 is 9. Bring down the 6w. Don't let the minus 6w disappear. On the right-hand side, I have 7w minus 3w. And you don't have to circle, I'm just doing that for illustration purposes. 7w minus 3w is 4w, and you're going to bring down that minus 21. Anything that you're not dealing with, you are going to bring down. And every line follows from the line above it. So if somebody said, where did you get a 9 from? You would say, I got it from 12 minus 3. If somebody said, where did you get a negative 3w from? Well, I got it from negative 3 distributing through the parentheses. Next step, get all the variables on one side. So again, I like to keep them positive. That's just how I prefer to do this. So this right here is a negative 6w. How can I get that to be a 0? Well, I can get it to be a 0 by adding 6w. If I add 6w to the left-hand side, I have to add it to the right-hand side and make sure that you combine it with other w's. Bring down that 9. We haven't done anything with that 9. Negative 6w plus 6w is 0. That's why it's gone. That's why it disappears. I don't really want you to write plus 0, but I do want you to understand the reason why it cancels out. 4w plus 6w is 10w. And now we have 9 equals 10w minus 21. At this point, we have a, I'm looking at how I did it in the notes. I did it differently in the notes. Now we have a two-step equation, and hopefully you can do this. If you don't like it written in this order, you can switch the order of the equal sign. If you're more comfortable looking at it like that, that's totally okay. Again, that's called the symmetric property. But we will undo this by adding 21 to both sides. 9 plus 21 is 30. Bring down that 10w. And again, they cancel because negative 21 plus 21 is 0. This is multiplication. Don't lose sight of that operation there. And I undo multiplication with division. 30 divided by 10 is 3, and 10 divided by 10 is 1, and 1 times W is just W, so we don't typically write the 1. So again, every step follows from the line above it. Follow the steps, like it'll be okay. So follow the steps. Hope this helps.